Hello friends, this is Florence Nova Christian from K. Shroff College. Today I am going to talk about Introduction to Finite Differences. In this session we will be dealing with what are forward differences, how to construct the forward and backward difference table, and how to find the missing value using the table. We will be seeing first of all what is the forward difference. We have under finite differences, we will be doing forward difference and backward difference. For a given table x, there are two variables x and y. The variable y is a function of x. There are different types of functions. Now here we are considering y as a function of x. If the values of x are given as x0, x1, x2, x3 and x4, the value of the function f of x0 if it is y0, and f of x1 is y1, f of x2 is y2, f of x3 is y3, and f of x4 is y4, then by subtracting two successive values of any functions, that is either the subtraction between y1 minus y0 or y2 minus y1 or y3 minus y2 and y4 minus y3 is called as the difference, and the difference is obtained by subtracting two successive values of the function. First of all, let us come to the operators. We see on the left side the operator delta is called the forward difference operator and the reverse delta is called as the backward difference operator. Let us see how to construct a forward difference table. The forward difference table, let us consider a function y equals to f of x. The operator is delta. So here we have the values of x are x0, x1, x2 and x3. The values of y are y0, y1, y2 and y3. The difference between the two function values, that is y1 minus y0, we get delta y0. This delta y0 is the first forward difference. y2 minus y1 is delta y1 and y3 minus y2 is given by delta y2. Again coming to the second forward difference, which is delta 2. We write it as delta raised to 2, but we call it as del 2. Del 2 is the subtraction between del y1 minus del y0. Similarly, the difference between the first forward difference, that is del y2 minus del y1, will give you del 2y1. Del 2y1 minus del 2y0 will give you del 3y0. This is how we construct the forward difference. The table remains the same in backward difference, but the notation changes here. Same we have x0, x1, x2, x3, y0, y1, y2, y3. y1 minus y0 gives rise to backward delta y1. Here we see in the forward difference it was delta y0 and here it is backward del y1, the below number, the below value, the below function. So similarly, y2 minus y1 will give you backward delta y2 and backward delta y3. These are called as first backward differences. Similarly, taking the differences of the remaining will give you the second backward differences, and finally we get the third backward difference. Let us solve a problem based on this. Constructing forward and backward difference table. Construct forward difference table for the following table. The values of the following table are 0, 1, 2, 3, 4 and y values are 15, 20, 18, 16 and 25. The difference between 20 and 15, we will take the values of x as same, x1, x0, x1, x2, x3, x4, and similarly we have y0, y1, y2, y3 and y4. To find the first forward difference, we subtract 20 minus 15, which is 5, 18 minus 20, 16 minus 18, 25 minus 16, which will give you the first forward difference. Similarly, the difference between minus 5 minus 2, minus 2 minus of minus 2 will become plus 2, which will give you 0. 9 minus of minus 2 is 9 plus 2, 11. 0 minus of minus 7 will give you 7. 11 minus 0 will give you 11. And 11 minus 7 will give you 4. This is how we construct forward difference table with the notation del f of x, del 2 f of x, del 3 f of x and del 4 f of x. Construct the table till you get the single value in the last. Let us see how to construct a backward difference table. It is similar to your forward difference. The notations will vary. Now here you can see how to construct a difference table given a function. Here the value of x and y values are not given. We are supposed to find the value of y. Y is given as f of x and the value of x is 0, step to 8. That is, your values of x are 0 to 8 and with a difference of 2. That is 0, 2, 4, 6, 8. When x is 0, the value of y is 1. Wherever x is there, substitute the value as 0. So 3 into 0 square minus 5 into 0 plus 1 will give you 1. When x is 2, the value of y is, that is f of x is 3. Wherever x is there, substitute 2. Similarly, for the remaining 3 values, you get the value of x and y. Again, the difference between the two values will give you the first forward difference, second, third and fourth. You can solve this preparing the difference table for the given function as explained earlier. Estimating the missing value from the table, the condition is given that the second difference is constant. Second difference is constant when it is given. Construct only up to second difference, and here it is given that second differences are constant. So our values of x are 1, 2, 3, 4, 5. Value of f of x are 2, 5, 7. The missing value we take it as a and 8. Difference between 5 minus 2 is 3, 7 minus 5 is 2, a minus 7, 8 minus a. Now here we have the difference between, again if you see here, 2 minus 3 is minus 1. A minus 7 minus 2 will give you a minus 7 minus 2. That is a minus 9. And again 8 minus a minus a minus 7 will give you minus 8 plus 7, that is 1 minus 2a. It is already given in the question that the second difference is constant. That is, if the second difference is constant, the first value which we got is minus 1. So the remaining values also should be equals to minus 1. When we compare any one value equals to minus 1, that is, here we are having a minus 9 as minus 1, then the value of a equals to 8. So this is how we can find the missing value from the given